Good morning, good afternoon. On behalf of SPAR3D.com, I would like to thank Cintoo for their sponsorship of today's event. Next, I'd like to welcome everyone to today's SPAR3D.com webinar, Cintoo Cloud, the platform to manage your terrestrial laser scans in a collaborative mode for scan-to-BIM workflows, presented by Cintoo. My name is Leslie Rosa. I'm the sales manager of our technology portfolio here at Diversified Business Communications. I manage SPAR3D.com, SPAR3D Expo and Conference, and the International LiDAR Mapping Forum. Before we start, I'd like to share a few housekeeping items that will help you maximize your enjoyment of today's webinar. First, to ensure call quality, everyone's line has been muted. However, we do want the event to be, as interactive as possible. Questions for today's presenters can be asked using the Q&A box at any point throughout the webinar. This is located on the bottom right-hand side of the webinar console. We will address these questions during a Q&A session at the end. Again, if you have questions for the presenter, please be sure to use the Q&A box. For non-topic related questions, you can chat with the event host using the chat box located above the Q&A box on the console. Should you have, should you have any audio issues, click on the phone icon, which is located above the chat box for assistance. Finally, should you be disconnected, you can return to the event using the instructions provided in your initial confirmation email. If you continue to experience difficulty, please email info@spar3d.com. And now, I'd like to introduce today's presenter. Dominique Pouliquin is one of the co-founders of Cintoo, a startup with offices in France and the U.S., developing a Cintoo Cloud, a reality data management and collaboration platform for BIM and AEC markets. He's the CEO of Cintoo US and is based in San Francisco, California. Dominique runs the product management and the business development for the company. Before co-founding Cintoo, Dominique held several positions, including product management and business development at AUTODESK in the Reality Solutions team. Dominique joined AUTODESK in 2008 through the acquisition of RealViz, a company that he co-founded and managed as the CEO for 10 years. RealViz photogrammetry technology was successfully integrated into several AUTODESK products, including 123D Catch, AUTODESK Recap, and AUTODESK Memento. Dominique holds a master's in engineering from École Supérieure d'Électronique de Louis in Angers, France. I apologize for the pronunciation. I do not speak French. Dominique, I will now hand it over to you.
Excellent. Can you hear me?
Yes. Thank you, Dominique.
Okay.
I can hear you.
Okay. Let me share my screen. Thank you very much for this nice introduction. I hope everybody can listen to me and see the screen. So I will run a few slides just to introduce the matter, and then switch to a live demo of Cintoo Cloud. So about 10-15 minutes of slides, and then I will do a live demo, and we'll keep 10 minutes at the end for a Q&A session. So yeah, talking about Cintoo first. Cintoo is a company based both in France and the US, as Leslie said. I started about 5 years ago, co-founded by 3 PhDs from a lab called CNRS, very famous lab in France, dealing with many different topics, including 3D compression technologies. So what you're going to see today is a result of many years of research of development on the core engine, on the core technology, but also 2 years of platform development. And we just completed a 3-month beta program that was very successful, with hundreds of users on thousands of scans uploaded. And I'd like to thank our beta team and also our beta users. There are some of them on the call. Thank you again for making this happen. So we just released version 1 like last week. And so this is all available now if you want to try it. So the matter today is terrestrial laser scanning. You are very familiar with that, so I will not go into the details of this technology that you all know about. The terrestrial laser scanning is booming in various industries, thanks to devices that are becoming cheaper and cheaper and easier to use, and this is good for everybody. So the technology that I will describe today on the Cintoo cloud is really covers all use cases of laser scanning. Could be in forensics, oil and gas, construction, but definitely the platform that we have built is really targeting the architecture, engineering, and construction industry on the BIM business in general. So we know that those devices produce a very dense and accurate point cloud, accurate meaning 2-3 millimeters to 8-10 millimeters. And this is something that you can now have natively in such products as AutoCAD or Revit with a very good experience. On definitely talking about AEC and BIM, there are two key workflows that we are trying to address with this platform. The first one being scanned versus BIM. That means its capability to constantly compare the as-built to the BIM model, to the original intent from the designers and the architects in a QA/QC process. And the other one being a scan to BIM, starting from an existing as-built for which you probably don't have any more drawings or updated drawings, and from which you need to build either drawings or a complete 3D model. So what is the problem that we are trying to solve with Cintoo? The problem is that there is definitely a cloud bottleneck today. The data that you produce with devices such as terrestrial laser scanners is gigantic. You know, each scanning position, each vantage point will produce data around 250 megabytes to 2 gigabytes of data. So if you end up scanning a complete job site, you end up with terabytes of data, really. So the problem that we are facing is that for the people that consume this data at the end of the day, being a Revit modeler or someone in the field, there is no other way to get this data than by receiving a hard disk or a USB stick. So in a global world now, you know, you're all in companies that have projects everywhere, being in the US or being in the world, and you need to scan a job site and then share this data with other stakeholders that are in very remote offices. So the way it's done today is absolutely not, doesn't make the reality data coming from terrestrial laser scanning very accessible, nor very collaborative. So at Cintoo, we developed Cintoo Cloud, which is a cloud-based platform that will attack this problem safely, and that will make the data really accessible to anybody in real time, make the data accessible everywhere, but also since accessible at the same time by anybody, it's very collaborative. So by making your laser scan really cloud compatible, we make them collaborative, and since they become collaborative, it's become part of the BIM process. But not only that, since the data will now be on the cloud, we can leverage cloud computing to run some deep analytics on using machine learning technology. We can extract meaningful information from that. So the technology that has been developed by the team is the core engine behind all of this is the capability to turn a point cloud into a surface mesh. And what we do create here is a multi-resolution, multi-level of details mesh that embeds wavelet compression that will allow to stream the mesh very nicely in real time from the server in a beautiful way. I'll show you that, of course, in the demo. But also, by doing this transformation, we really decrease the size of the file. So let's say you start with 100 gigabytes of data as a point cloud. We will divide this size by about 15 to 20. So that the data that you end up uploading to the cloud will be more around 5 to 6 gigabytes of data. So starting from 100 gigabytes, on uploading finally only 6 to 8 megabytes. It's 6 to 8 gigabytes of data. But the good news is that we keep track of the mathematical model of the sensor, so we're able at any time to retrieve back the point cloud in its original form. And so still you have your 5 to 8 gigabytes of data in the cloud, but you can get back your 100 gigabytes of data on the desktop, anywhere, if you want. This is really the core technology that we have been developing, and you will experience that in a minute, in a few seconds during the demo. So if you compare the source point cloud that was scanned by the device, that was registered using any registration software being Recap, Parocene, Cyclone, etc. So you start from this registered point cloud, we create a mesh, and this is what will be uploaded to the cloud. And again, the data will be divided by 15 to 20. But as I said, you can retrieve back the point cloud in its original form as a structured point cloud or a unified RCS. And if you compare the source point cloud to the reconstructed point cloud, you will hardly notice any difference. We have a sub-millimeter difference due to the compression, which is something between 0 and 0, let's say 0 and 1 millimeter maximum, but more on average around 0.5 millimeter, which is much below the noise of the scanner itself anyway. So there is no compromise on accuracy by doing this complete process. Let me show you 2 examples of what does that mean having a mesh in a browser instead of a point cloud. Let me switch to the platform. I will run a complete demo of the platform just to show you now the quality of the mesh we had. So this is typically a laser scan, RGB laser scan that you will experience in any other software. But now this is a photo texture mesh. So if I remove the texture map and I go to the surface mode, you will really see what the laser beam has been capturing, okay? So even if you have overexposed areas, like here, you have a very strong overexposure here, look at what the laser beam has been able to capture. And if you look at, I go into some details here, you see the quality of the mesh that we produce is really fantastic. So by this technology, by transforming to a mesh, we really reveal details in your laser scans that you have never seen before. Let me show you another example here. This is another scan, thanks to our friends at AGP in France. This one has been scanned without any color, just the intensity. And you see, this is what you see typically, but you see almost nothing. Now, if I switch to the surface mode, so I remove the texture mapping, this is what you see, okay? And you see all the details, every single detail of your project, up to the very fine details, of course, depending on the resolution of the scanner. But this is what you can get as data to work with. Instead of showing this, I put back the RGB. You see almost nothing. I go back to the surface mode, and this is what you get. Okay. So there's definitely a very good opportunity here to leverage your laser scanning in a much interesting way, revealing details that you have never seen before. Let me come back to the presentation, and then I will switch to the full demo in a few minutes. So Cintoo Cloud is not only this technology, it's a complete platform, including data management and collaboration features. So one of the data management is about organizing your projects. So let's say you have a project of 330 scans here. This is an hospital somewhere in France. What we allow to do is to organize the data in a work logic area. So in this example for here we have the data. So say the laser scan data has been organized by levels, by rooms. You see the attic has 4 scans. The basement has 217 scans. The first floor has 31. The kitchen only 8. So let's say now you have a colleague that needs to work on the kitchen. So the kitchen has only 8 scans. So he only needs to see 8 scans at a given time, and this is what we allow in the viewer. But also, if he's willing to work in, let's say, in Revit, he needs to work on this work zone. he only needs to download only 8 scans and transform it back to either a point cloud in E57 or RCS. So instead of importing, I would say, 330 scans in Revit, you end up using only 8 scans for this particular job. And this is really changing the performances of Revit, as you know. So this is the work zone organization that we do provide with the platform. I'll show you how we create work zone. It's very, very easy. Another interesting aspect is the collaboration aspect. So definitely the key persona for the platform here has been the BIM on the VDC manager. And the platform allows you to invite users, to assign those users as team members to any project, to send them notifications, something like that. Okay, so it's also connected to the BIM platforms. I'll show you that. And so this is really about collaborating on the reality data in a very new and different way. Nicely, the Sparse 3D team calls the Netflix for 3D data, which I like very much, but definitely we need to expand a little bit more. So let me show you the complete workflow now, and then I will switch to the main demo in a few minutes. So we start by gathering data from the field. So the data has been captured using any device. We are platform agnostic, hardware agnostic platform, sorry. The data has been registered using either Recap, Pharo-Scene, Cyclone, whatever. You just generate either our RCP file with Recap or E57 structure file from any other software. And what we do, we have this Cintoo Connect, which is a small Windows app that will run locally on your desktop, and that will transform this structure file, a structure E57 or RCP, into our Cintoo mesh, and will upload automatically the data to the cloud. Once it's in the cloud, we have a web app that will allow to view, manipulate, add metadata to the project. Cintoo Cloud will also be connected to the BIM platforms. The use case here is to be able to pull the 3D BIM model from those platforms and view that, overlay to the reality data in our viewer, and to do some diff analysis between the reality data and the BIM model. And the other workflow that we support is, of course, Scan to BIM. In this case, we also use the same Windows app, Cintoo Connect, to download the mesh and transform it back to a point cloud in E57 or RCS. So this is what we call the Cintoo solution, Cintoo Cloud solution, where, as I said, the version 1 is now available, and you can start testing it from our website. It comes with a complete workflow that can, as I said, read E57 RCP and produce E57 or RCS files. Talking about, last point, we will show at AU in 10 days from now, we will show this connection with BIM 360 and BIM 360 docs. That will be a demo that we'll be making at AU for a release that will be in a few weeks later. Talking about Autodesk compatibility, this is what we have today, as I said. So we can read registered scan projects from Recap Pro. We can create then either crop sections. You can turn back scans or a single scan or a set of scans back into a structure point cloud or unified point cloud as well, either work zone or a full project. By AU time frame, leveraging the Forge platform, we'll be able to demonstrate this connection to the BIM platform, to the BIM 360 docs. Just an example of what we do. So Scan to BIM, for example, you can create crop sections in the platform, and I will demonstrate that in a minute. And those crop sections will be exported as an RCS file that you can natively read in AutoCAD. This is just one workflow as an example. Another one will be, you have a work zone, and you need to turn it back as a structure point cloud in Recap. And then we use E57 as an export here. And then you get back your point cloud in Recap as a structure one. Okay, or you can have a unified RCS as well. Talking about Scan versus BIM, this is what we will be showing at AU later, in about 10 days from now. So you would connect to BIM 360 docs where you have your BIM model. The BIM model will be imported in the Cintoo Cloud platform using either RVT or IFC format. So now you have in Cintoo Cloud, you have both the BIM model, you also have the reality data. We assume that both are aligned for the moment, and then you can compare the BIM model to the reality data and make a visual diff. Of course, today we make a visual diff only. Tomorrow we'll be able to produce an automatic diff analysis and create a report for you or your customers. So these are the workflows that we allow today, and now let's switch to the demo. So for the demo, I'm using Google Chrome. The platform runs well on Google Chrome. We need to have a WebGL browser, so we really recommend Google Chrome. I will log into aec.cintoo.com. Let me start from the beginning. I will log out first. So log in to Cintoo Cloud, aec.cintoo.com. The first thing I will see here is a dashboard. The dashboard is the one that you have as a BIM manager. You see all the latest activities on your projects. You see who has been using what. The first good use of the dashboard is to list your users. We have, with this platform, unlimited users, so you can invite as many users as you want. And you can assign that, so you just invite them by an email. And you can assign them with roles and permissions. So we have preset 5 different roles. First one being a BIM manager, a surveyor, a modeler, a superintendent, or a viewer. And for each one of them, you can limit, I would say, the access you have to the data, being from uploading data to simply viewing or adding notes or measurements or exporting data. And if you are not happy with those presets, you can also define your own custom roles. So then I switch to my projects. So this is a list of projects I have now on Cintoo Cloud. I can view them as thumbnails. I can increase the size of the thumbnail. I can view them as a list as well. And in the list, you see all the people that I invited to participate to each one of those projects. I can view them as well through a map. I can zoom in here on San Francisco. I have a few projects in the area here. And then coming back to the list here, or to the thumbnail, sorry, you can also have information about the project. So for example, here in this project, about 60 scans, 2 gigabytes of data being uploaded. So I probably have something like 400 gigabytes on my disk for the same project. What I'm going to do first is how to create a project. Creating a project is very simple. You just click here, creating a new project. You assign it to a plan. This is linked to the monetization. I will come back to this later. You give your project a name, call it webinar test. Sorry, webinar test. Okay, you can give a description, you can give whatever, set it as active. Interesting here, you can of course geolocate your project. You can define where the data will be hosted. So this is a very interesting feature that we provide. Since a cloud-based solution, we use either Amazon or Azure. So either you let it go, and it will be somewhere in the cloud, probably on Azure, and then let's say you have a project in Arkansas, but you have a viewer or a stakeholder that needs to access the data from London. In this case, with the automatic setup, we use what we call Content Delivery Network, so CDN. So probably the data will be duplicated somewhere in the cloud close to London, so that it will improve the streaming performances. So the good point is that the data can be anywhere, and you have the best performances. The con, I would say, is that you don't know where the data is. So you can select another option, which is, I want my data to stay in the US, for example, or Western US. So you select the region. I say this data needs to stay in the US and it will be on Amazon. Or I can say this data will stay in the US and will be on Microsoft Azure. Okay, and we are adding more to the list as we speak. In which case, the data will always remain in the region that you selected. And so again, if the person is trying to access the data from London, he will fetch the data from the data center. There will be no duplication of the data. So you can commit to your customer and say, okay, the data will remain in the US, no doubt. And we also have the option to have the data in your own private data center. You have just to speak to us about that. So I just create a project here. So the project is added to my list. Now I click on this project, and the first thing I have to do, of course, is to upload data, to upload laser scan data, eventually Revit models or IFC model as well. That will come later. What I do here when I click prepare on upload, I will run this Windows app called Cintoo Connect. It's, as you can see, Cintoo Connect 1.0. And I will select the files that are on my disk. I can select this small project. This is a BLK 360 project, E57 or RCP. I select the E57. These are all the 20 scans or 16 scans of this project, and I click import. So what's happening now is that locally, we are running this transformation process from the point cloud to the mesh. And when it's done, the automatic upload will start to the platform. And this is a batch process. You can run multiple Cintoo Connects at the same time, run it overnight, whatever. It takes about 1 minute per 10 million points for the transformation. Okay, so I will let it go and go back to a project that has already been uploaded to see the features of the platform. I will use this one. This was interesting. It has 60 scans. There are both Faro scans, DNF scans, and Leica scans. So the data has been uploaded. You can see here we have three ways of accessing the data. The first one is the data. This is the list of the scans here, as you can see. You can also see them as thumbnails here, which is another way to go. You can also have an overview map on the 3D view. I'll come back on this. The first thing you may want to do when you have created a project, when you have uploaded data, is add team members. So by adding team members, to add team members is very simple. You have your list of users. You remember we added users as the first step. Now we turn those users into team members for this specific project. For example, I will invite my colleague Anis here as a BIM manager, or I could be a surveyor type of person here, or can be only a viewer, and I will add him as a viewer. Okay, when I say save here, Anis will receive an email saying, okay, you have been invited to this Oakland train station project, and so you have access to it now in your own dashboard. So coming back to the data now, you see also panoramas. The first thing I'll do, I'll go to the 3D view. The 3D view is really where you have a typical point cloud view. So now what's happening is that we're streaming the 60 scan data from the server. In this case, the server is based in the Netherlands. It's an Azure server, and you see how fast we stream the data and how fast we get the data. So this is a 3D navigation mode, and the data will continue being streamed as we get closer to any one of the area of the project. I have my various scans positioned here, as you can see. We can also switch to various display modes. So this is the RGB mode, but let's switch to this X-ray vision mode. I like it very much. X-ray vision really will help you understand your project better, because you see through the walls, like you have an MRI of your building. You still have all the scan location, okay? Or I can switch as well to the surface mode. And you see we have this backface culling tool that will allow to see through the walls as well, because with the backface culling, since what we're looking at now is a mesh, it's not a point cloud, we will not display the surfaces for which the normal is not towards the camera. Okay, so from any angle, I will always see the inside of this building. Thanks to the backface culling. Okay, so now I can also switch to any single panorama. I click on one panorama, and this is where I see the full resolution mesh. Look at the mesh here. For example, this is what you got from the RGB sensor. So the RGB sensor here for this particular scan position doesn't really help. If you zoom in, you see nothing. But if you look at the surface, then you see really what the laser beam has really been capturing. So I'm guessing that you see the difference here. And we have a very high resolution mesh. So for example, if I go to this one, so you see the mesh is being streamed in real time with the various levels of details. And if I get closer to this, you will see the quality of the mesh that we get from this reconstruction process. So instead of viewing this is what you see usually. You get this now. Okay. So what you can do now in the 3D view mode, you can do measurements, annotations. Let me show you. Before starting a measurement, you can go to the options and select which system you want to use, either the metric or imperial system. Imperial can be international or US, and you can even select the precision of the measurement. Now, if I do a measurement, I go to the measurement tab. I will add a measure here. I have my measurement here, and I save the measurement, call it measurement 1. I save it. By saving it, I will create a thumbnail here on the left that will list this measurement and give all the details. You can edit the measurement or delete it. Let me add another interesting feature here, which is the annotations. Annotation can be, so I click on add annotation. I click at any point in my panoramic view, and I can add either a note, a private note, or an issue. If it's an issue, I give it a name, say to be checked, for example. I can assign it with some severity parameter, ask for a due date, add text, photo, video, URL to a database, whatever. And I need to assign it to a team member, so I will assign it to Anis, my colleague here. And when I click validate and create annotation, Anis now will receive an email saying, okay, you have to check here, there is an issue for you to be solved. And all the same, we save it with a thumbnail. So you can add here as many measurements, as many annotations as you want. These are the metadata that will be added to the project. And you can also create a report now with this data. You say, I want to create a report from every users for all the activities. And I say export. So what is being done now, we are producing a PDF file that will list all the data, all the metadata that we added to the project. So now it's being downloaded as a PDF. And if I click on the PDF, this is what you get, okay? You have your issues here with the thumbnail, and you have a measurement here with the thumbnail as well, on all the details. Okay, let me come back now to another interesting aspect, which is the 3D view, which is the capability to share. Either for sharing projects, you know, point cloud project is always difficult. We do provide two solutions here. Either you invite team members to participate to your project, and this is what I just showed, or you have also a sharing option here. In this case, the people that you will invite through with a simple email, they don't need to be part of the platform. They don't need to log into the platform. They will receive an email that will give them access to the 3D viewer only. So they will still be able to experience everything I showed you in the 3D view, including the surface mode. They will be able to do measurements by themselves, but those measurements will not enrich the metadata of the project. And you can password protect your email. You can also give a limit in timing. And then you invite anybody you want. Again, we have unlimited users with this platform. Another interesting view mode for this project is what we call the overview map. The overview map is a set of orthographic views of your project from any angle. Starting with the top view here, we have the top view here. When I put my mouse over one of the scans, you see in yellow the capture area for the scanner for this specific scan. But let me switch. So either you can view the overview map as a RGB. Let me switch to X-ray vision again. I like it very much. So this is the top view of your project. The side view. This is a rear view, etc., etc. So you have all the various views of your project from any angle. And what you can do here is very stuff that are really interesting. For example, I told you about those work zones, okay? Those work zones, the capability to assign scans to a specific work area. So here, for example, I have a few scans that belong to the inside of this building. So what I will do, I will create a work zone corresponding to the interior of the building. In order to do that, I go to the work zone tab. I select the rectangle tool here. I select all those 9 scans that are inside the building, and I click here on the right, Add Work Zone. I give it a name, I call it Interior, and I create a work zone. And you will see in my Project Explorer on the left-hand side, I now have a sub-folder called Interior that has 9 stations or 9 scans in it, okay? So if I click on only this one, I will only display 9 scans corresponding to the interior, and switch again to the X-ray mode, X-ray vision mode. So this is my subfolder, having only 9 scans. And I will do the same with the 3D view, for example, and I'll show you how you can export that back in E57 or RCS. Let's come back to the full project. So I have created the first work zone here. Let me show you another cool feature, which is a crop tool. Again, this is a top view of my project. Switch back to the X-ray vision mode. The crop view is a capability to cut any slice of the project in any direction. I also have a rotation tool here where I can align my project to the grid of the screen to make sure that the auto views that I will be able to export are really orthographic to the screen. This is not changing the coordinate system at all. Okay, but let me show you the crop tool. So in order to show you the crop tool, I will go first to the side view of the project. I will use the crop tool here. I open the crop tool. You have these 3 sliders here. So I will do a crop in Z first. So I will adjust the Z here to extract a section of my point cloud, or my reality data, I should say. I can browse through it, so I can select the best section I want. Or if I look at that from the top view now, this is a section I've selected, but I can adjust that. So you see, it's like having an MRI of your building, okay? You really are able to select the best possible slice that you need for, let's say, a 2D drawing, okay? So once you have selected the best slide, what you do, you click Add here, and that will save this crop in my list of crops. I can have as many crops as I want. I can edit them, I can delete them, but I can also export them. So if I click Export here, what will happen? Again, I will run the the Cintoo Connect Windows app, but now to export the data back into a point cloud, okay? So what I will do, I will select a destination file on my disk, on the desktop, select the folder, and I say Export. So what's happening now is that the mesh data for this particular section or this particular slice is being downloaded first and inversely transformed back into a unified RCS point cloud. And of course, I already did it before this presentation. So let me show you how it looks like in AutoCAD, for example. I have here a drawing. made in AutoCAD. And so if this exact same slice, I'll show you that now as a RCS point cloud in AutoCAD. And this is a direct import. You don't need to go through a recap to do that. So opening AutoCAD now with this RCS file. So you can have sections that could be horizontal, vertical. You can use them for scan to beam in Revit. You can use them for 2D drawings in AutoCAD, whatever. Sorry, it's taking some time to start AutoCAD. And this is a result of my crop exported as a RCS point cloud in AutoCAD. Okay, and then you can use the AutoCAD set of tools to draw your drawings here. I will not do this demo. Of course, you are very familiar with these kind of tools. Okay, so coming back to my project here, this was again selected through this overview tool, overview map tool. And the cropping tool is really very interesting. You should take a look at that. Another aspect is the export of the data. This is one of the, I just showed you one example of a scan to beam process. Another one will be to be able to export the data and get back a structure E57 or a unified RCS. So what I will do here, I will select, for example, the interior. The interior has only 9 scans. Okay. Go to the list mode, or just select all the scans this way. What I do here, I click download, and again, download will run again Cintoo Connect, Windows app, for the same purpose that I just showed you. So I select the destination file, destination folder, and I say export. So what's happening now is that every single scan that I selected is being downloaded first, and we inversely transform that back into a point cloud with no compromise on accuracy, as I said earlier. And that will give you either a structure E57 or will give you a unified RCS as well. So unified RCS is coming very soon. It's something a matter of days now when we have this option available in Cintoo Connect. Okay, this inverse transformation is much faster than the original transformation. It would take, you see, it takes only a few seconds per scan. And you see, in this case, I have multiple Cintoo Connect selected. So you see, remember, I started this project. I started the upload of this project at the beginning of the session. It's almost done now. I only have one scan to upload, but I can go back to the project now, my project list. Look at my webinar test. And here is my data. The data has been uploaded while I was speaking. Oh, sorry, I didn't click on the right project here. Webinar test is this one. This is a BLK 360 data. If I look at that from the 3D view, and this was done in real time while we were speaking. I was speaking. So again, by using the backface culling, I will always see the inside from any angle, even from below. Okay. And again, if I click on any of the scans, I will see the photo texture mesh with all the problems you may have with the overexposed or underexposed area. But if I look at the surface mesh, I really see all the details of my project. Okay. Of course, the overview map is also available. And if I slice this again, I can use a slice in the y-axis, for example, here. look at this from the side, and I really have the MRI of my building. I can select the best license I want. Okay, this is the end of my live demo. Let me come back to some slides here to conclude before we go for the Q&A session. So as a summary, I would say Cintoo Cloud, Cintoo Connect, this is a reality data management and collaboration platform that is completely hardware agnostic, that will manage your reality data from terrestrial laser scan in the cloud, that will make your laser scan really truly accessible by anybody at any time, anywhere, that empowers collaboration on reality data, and that enables scan versus beam and scan to beam workflows. So if you want to know more about Cintoo Cloud, a few ways. First, you can go to cintoo.com. We have a free trial available, and soon you will be able to purchase online as well. So a few words about monetization. What we do, what you will buy from us eventually, is a capacity on the duration. So let's say you have multiple projects running, laser scanning projects that are either small or big. And yes, let's say on average, you need to have access to a few projects that total 200 scans per month. I didn't mention that, but your projects can be active, in which case they will be part of your capacity. But as soon as a project is no more active, you can set it to archive mode. In archive mode, the data will remain in the cloud in some kind of idle mode, and they are no more active, so they are not part of your capacity or your active capacity. So let's say you have 10 projects of 20 scans, you need a constant capacity of 200 scans, and you did it for 3 months. This is what you will pay for. Okay, so pricing is based on the number of scans that you upload. Whatever the resolution of the scan is, can be a 10 million point scan, it can be a 160 million point scan. We don't care. It's for unlimited users, as I said. Prices will start around $5 per scan per month, down to $1 per scan per month, depending on the capacity, depending on how many you need. Okay, so please call us. Tell us what your project is, and we will find a solution for you. Another way to go is to come and visit us at Autodesk University. This is in 2 weeks from now at the Venetian in Las Vegas. We have a booth there, booth 8520. You will see a live demo of everything I showed you, plus the connection to the BIM 360 Docs platform. And of course, please contact me for any other detail. I'm available at this email address, pouliquin@cintoo.com, or through sales@cintoo.com as well. Leslie, this is the end of my presentation. I'm happy to answer some questions if there are any.
Wonderful. Yes, thank you so much. That was a great presentation. Certainly know that this is a big issue for a lot of our audience out there, so certainly appreciate the in-depth presentation. We do have a couple of questions that we'll get to before closing out. Let me just get through our chat window here. So a question from Kathy. Kathy asks if you have a embeddable web viewer.
That's a great question. Not available at the moment, but this is on our roadmap. So we can certainly discuss that and see what kind of priority we put on this one. But yeah, this is an option that will be available. It's not yet available though. Great,
thank you. Just scrolling to get through some of these here. I apologize, I'm having an issue scrolling up in my Q&A box. Okay, another question coming in. I apologize, guys. Having a difficult time getting up to. Question from Ryan, curious if this works on a iPad or a phone tablet?
Yeah, another great question. This is again on our roadmap. So far, we don't support the iPad or smartphones. The only reason is that we don't support the touch screen. Okay, so the technology definitely, as long as you have a WebGL browser, you could view that on any mobile device. But for the moment, you need a mouse on the keyboard to navigate. So once we have the touchscreen option, and this is on our roadmap as well, this is something we will provide absolutely.
Great, thank you. Question from John. John asks, does the meshing and compression work for unstructured and or mobile scans?
Not at the moment. This will be something we will consider in 2019. So no, for the moment we import only structured data. So we need to have a terrestrial laser scan that provide vantage points with depth maps, with a point cloud, with a panoramic image, and this is the kind of data we need as an input. So structured data in E57 or RCP, this is what we need. Reading mobile LiDAR data like indoor LiDAR or outdoor LiDAR or even drone data is something we plan for the future, absolutely, but not yet.
Great, thank you. We'll have one more question here, and I apologize if I've missed anyone. Again, you can reach out to Dominique directly. If there's any other questions that we can get to, you can certainly reach out to our team here as well. This last question from Stephen. Stephen asks, can the mesh be exported?
Yeah, this is another great question. Again, all the questions are great, of course. No, exporting a mesh is not today possible, but this is something we're working on as well. One of the reasons why it's not possible, the mesh that we produce is per scan is really huge. There are millions of triangles in each scan, in each mesh for each scan. The reason why we can view that in the browser is because we use streaming technologies. Okay, it's like a little bit like Netflix is streaming very heavy videos on your TV screen. So we use streaming technologies that allows to view any size mesh in a browser based on the viewpoint. So if we were to export a mesh like that, there would be millions and millions of triangles, and there is eventually no software that can read that today. No desktop app, I would say. So what we're working on is a capability to select a crop section, as I showed you, and instead of exporting that as a point cloud, as a RCS point cloud, we'll be able to export that as a mesh with multiple levels of details. Give us a few months more. This is something we plan for Q1 2019 or Q2 2019, but that will be possible, but not today.
Great, thank you, Dominique. So we will now take a moment to wrap up today's webinar. Thank you, Dominique, for presenting today. It was a great presentation. Cintoo sponsored the webinar as well today, so we certainly appreciate not only the presentation, but also the sponsorship of today's event. Before we sign off, we do have a remaining few bits of business. Certainly stay tuned for a follow-up email on accessing the on-demand version of today's program. We're always eager to receive your feedback, so please complete the short survey that'll appear when you log out. And you can certainly connect with me directly. You can find me on LinkedIn, email me directly at lrosa@divcom.com. My contact information is right there. And thank you. Thank you for taking the time to attend today's spar3d.com webinar. I do believe Cintoo will be presenting again early on in the new year and certainly participating with us in the future. So thank you again, Dominique and Cintoo, and have a great day.
Thank you. Bye-bye.